Alright, so we start today with actually quite a few definitions. None of them are super difficult, but these are all important to be able to recognize these. So to start with, I guess let's just take a look at them. Now I've typed them out, I'm going to reveal them, and then you guys can pause and make sure you have a definition. If it's not perfectly in my words, that's fine, but you do need to understand the gist of it. So, variable. Variables, quite simply, are some kind of a symbol. Usually it's a letter. I mean, I guess you could use a triangle or a square or something like that, but usually a letter that stands for a number that can change. So maybe you've got a variable that's going to stand for the cost of a can of soup. Okay, can of soup costs $1.99 today. It goes on sale tomorrow. That could change. But when we're talking about the cost of a can of soup, we could say, well, we're going to use we're going to call that variable. There we go. Say, that'll work. So a variable could be C for our cost of a can of soup. We could use a different variable to stand for some other number. Usually we pick some letter that relates to it. Sometimes if we're just kind of doing this as pure math or algebra-ish stuff, we're going to use the variable x. I will always do it sort of as a handwritten looking x like this, so you don't confuse it with a multiplication sign. But really any letter can stand for and be a variable. All right. An expression. So an expression is some kind of a mathematical statement in which a variable is multiplied, divided, added, or subtracted by other variables or constants. Important thing when we're dealing with this is that there is no equal sign in an expression. Now I can turn an expression into an equation by telling you that it equals something, but an expression by itself means that there is no equal sign. So if you think back to like the formulas we've been dealing with for the area of a circle or the circumference of one, those are not expressions. They're not expressions because they have an equal sign. All right? So an expression might be as simple as, well, thinking back to our can of soup, right? Which we said the cost of our can of soup was C. If I go and decide I'm going to buy 8 cans of soup, the cost, I could give an expression for that where the total cost would be equal to, I've got 8 cans of soup, so 8 times the cost of 1, so 8 times C. Now, normally I don't write the multiplication symbol in there like that, and so what I would actually write this as is 8C. Now they mean the same thing, but this is the one that you're going to see written down, and I want you to get used to writing that as well. Alright, this takes us on to our next term. So pause if you haven't written those down already. Next term here that we're dealing with is the term value. And when we deal with the term value, is simply the number that a variable stands for in a particular expression or equation. So if I'm deciding, well, what is the value? Okay, so again, I kind of gave this away up here, right? A variable stands for a number that can change. If I tell you, well, today my can of soup costs $1.85, then the value of that variable would be given by C, the cost of a can of soup, equals one. Ooh, that's a terrible dollar sign. There, got a bit better. $1.85. Right? That could be what it's equal to today. Well, maybe the can of soup goes on sale tomorrow, and tomorrow it's $1.25. Well, then I would have a different value for C. Next week, they're out of that kind of soup. They get something different in, and now it's $2.25, or that type of a thing. So anyways, when we're talking about the value is a number that a variable stands for in a particular expression or equation. All right, well, this takes us on to our next one. Again, make sure you've got that down. And this is constant. All right, so a number in an expression or equation that is added to or subtracted from a variable. So in our can of soup situation here, we don't have a constant that we're talking about. We have dealt with a numerical coefficient already, but we'll get to that in a minute. But a constant might be some number that we would add to it. All right. So giving you an expression here, 8y plus 3. Well, this number 3, that is the constant. Right? It will not change. So, the word constant, that's what that means. It doesn't change. But it is, in our expression or equation, some number that's added to or subtracted from a variable. So 8y plus 3, well, the 3 is our constant. 8, I'm picking on the number 8, I'm not sure why. 8j minus 5. Guess what? The 5 is now our constant. Right? So again, pause, make sure you've got the definition down. And then we move finally on to numerical coefficients. And numerical coefficient is simply a number multiplied or divided by a variable in an equation or expression. So, for example, the one we were just talking about with the cans of soup, well, 8c, there we go, that number 8, that is our numerical coefficient. Right, remember the c, that was the variable. And then, one thing that you might see you get asked to do at some point is, well, evaluate this expression of 8c when the value of c is, going back to our price before, $1.85. Well, when c is equal to $1.85, so c has that value. I could evaluate this expression and find out, okay, well, 8c is the same as 8 multiplied by 1. And let's try that again, I'm sorry. Alright, so again, if I'm saying c is 0.85, and our expression again was 8c. To evaluate that, I'm simply going to go 8 multiplied by, and I can just show multiplication by butting the 8 right up against the bracket. 8 times $1.85, and then I can punch that into my calculator. 8 times $1.85, and I'm going to get 14.80. Right? So that would be how we would evaluate that particular expression. Again, where the 8 is the numerical coefficient and the c is the variable. Right? Another way, a different type of an equation, or let's go with an expression here. N divided by 3. That, in this case, the 3 looks like it is a numerical coefficient here. Okay, as you move on, you're going to find out that we can use it, say the numerical coefficient is 3, or we could look at this and say, well, the numerical coefficient here is actually 1/3. Okay, but we're going to, at this point, I'm happy with either. So let's move on. Look at some examples. All right, so here's where we are going into the fun of translating English into math. We're starting with some easy ones, but we are going to have a little bit of work to do. So 3 employees work at the food bank. Every day, some volunteers arrive to help out. What is an expression for the number of people working at the food bank? What is the value of a constant? Here's another place where this word value comes up. Value is simply, I guess, telling us what a number is equal to. Often we use it to talk about what is the particular value when we're talking about a variable. We can also say what is the value of the numerical coefficient, as in what number is it? What is the value of the constant, as in what number is it? So in this case, 3 people work at the food bank. That's the constant. There's always 3 people. Every day some volunteers arrive, so our expression is going to be those 3 people that are always there, plus our volunteers. Let's call them V, because that goes with volunteers. Usually we're going to pick our variable to help make sure that we know what we're talking about. So expression for the number of people working at the food bank would be 3 plus V. What's the value of the constant? Well, the value of the constant is 3, because there are 3 people that always work there. All right, example number 2. We have Teresa sharing some grapes. So nice of her. Equally among her 4 friends. So we got to figure out, first of all, is Teresa eating some grapes as well? We're going to assume she is. So how many people are there? Well, there's her 4 friends, and she is also a person. So there are 5 people here. Number of grapes each friend gets? Well, if she has the number of grapes, let's call that G. Each person is going to get G divided by 5 grapes. Right? G over 5 means G divided by 5. We could also write this a different way. G divided by 5. But this way is the better way. And again, as you move on into grade 8, grade 9, grade 10 math, you're going to see this way being the one that we use, not with the division sign. All right, so this is assuming, again, Teresa and her friends are eating, which makes, 4 friends plus Teresa would be 5 people. I suppose if, I don't know, Teresa is allergic to grapes and refuses to eat them, then we would have a different expression. There it would be G divided by 4. All right. Now, example 3. This gets to be a long statement here, but it's not super difficult. Group of students are talking between classes. 2 friends leave the group. What is an expression for the number in the group after the friends leave? All right, so we've got a group of students. Talking between classes. 2 people leave. Oh, that looks like a constant there. So, group of students, pick a variable. I'm going to choose S for students. You could use G for group. I really don't care. They're talking between classes. 2 people leave. Oh, so after friends leave, we've got S minus 2. So label my variable. My variable is right there, S. And S is equal to the number of, is equal to the number of students in the group. Here's my constant. 2 people are leaving. No matter how many people there were there to begin with, 2 have now left. You might say, hold on, there's no numerical coefficient here. Actually, there is. If there's no number in front, what is a number we can multiply by S that would not change it? Of course, that's going to be 1. So our numerical coefficient is going to be 1. Because again, 1 times S is the same as just S. Alright, that's something important. We don't use it a ton right now, but we will definitely get to talking more about that. Alright, example number 4. You walk into a store to buy 4 boxes of cereal. What is an expression for the cost of 4 boxes of cereal? Well, let's put cost as, I don't know, C. So C is my cost. I've got 4 of them, so my total cost is going to be 4 times C, or 4C. All right. Simon is creating this pattern of toothpick triangles. What is an expression for the perimeter of any triangle in this pattern in relation to the base? So we got to look and say, okay, well, the perimeter compared to the base. So if we look at this, we can say, well, perimeter, this seems like a good thing that we could go for P. So perimeter, here we go. That's going to be our variable, is P. All right. So the perimeter of the first triangle, make a little table here. All right. Perimeter and the base. So the first triangle, perimeter, distance around the outside is 3. Base is 1. This one here, 1, 2, 3, 4, 5, 6. Perimeter is 6, and the base is 2. I am going to run out of space very quickly here. But the next one, perimeter 1, 2, 3, 4, 5, 6, 7, 8, 9. Base is 3. Hey, I noticed something going on here. If I take the perimeter and I divide it by 3, I will always get what the base is. So in terms of a expression that's going to give me look at the perimeter of any triangle in relation to the base, I could say, well, the perimeter divided by 3, that gives me the base. Or, as I look at this wording here, perimeter of any triangle in this pattern in relation to the base. Another way to look at this is to say, well, how do I go from the base to the perimeter? Oh, if I've got the base, it's 1, perimeter's 3. Hey, I multiply by 3 every time. 2 times 3 is 6, 3 times 3 is 9. So this would give me, P divided by 3 gives me the base. I could also look at this, in this case, a better answer is going to be not perimeter divided by 3, but it's going to be 3 times the base, or 3b. This is an example of where you have to look really carefully. And actually, one of the things as we move further into this and start looking at equations rather than expressions, this becomes easier. Because when I turn this into an equation, then it becomes very clear what we're after, where 3b is equal to the perimeter. Basically turns into a little bit of a formula. All right, so your assignment, again, we look at the very beginning. This is section 10.2. So for those of you whose textbooks are a little bit goofy numbered, use that to help yourselves. And I'd like you to do 1, 3, 6, 7, 8, 11, 12, 13, 14, 15. If you have no problems with any of those, move on and give a try to 16 and 17. Thank you.